Hi everybody, we are taking a look at two-way tables and probability. You can see there's a bunch of vocabulary terms here. So what you're going to want to do is copy these down. The first thing we're going to look at is a two-way table. You'll see an example of it, but it's basically a table that has two different categories in it. They always put these on standardized tests like the SAT, the ACT, so I see them all the time. So that's called a two-way table. I'll show you a couple examples. Joint frequency is each entry, so each part of the table. Marginal frequency is when we add up the rows which go this way or the columns which go this way. Joint relative frequency is when you take the ratio of something to the total. And marginal relative frequency would be the sum of the sum of the joint relative frequencies in a row or column. And then you can see conditional relative frequency, the ratio of a frequency that's not a total to the total. Okay, so this all sounds crazy and I get it, but you just want to have these definitions so that when we get to the examples, you know what they are asking. So I'm definitely going to help them out. So feel free to pause the video here, jot these down so you have them, and then when you're ready, hit play and we will move on to some examples. Okay, so this is what a two-way table looks like, although usually it's filled in all the way. And we're going to fill it in, that's what we have to do. But you can see that there's the method of transportation and there's also the arrival. So that's what I mean by where it says up here. So two different categories. So the categories here are the method of transportation and also the arrival, right? So it's a way of organizing your information. You put one over here and you put one over here. So we basically have to figure out what numbers are missing. Well, basically the total, this plus this should equal this. And the total here, this plus this should equal this, okay? Down here is the total tardies plus the total on times equals the total. Over here, the total walkers plus the total bussers equals the total. So let's start here. If the total is 130 and part of it is 60, then this has to be a 70. And if the total is 130 and part of it's 58, this has to be a 72. Now we can move up this way, right? So if the total is 72, part of it is 22, this has to be a 50, right? So I'm just subtracting. And now we can go this way. 50 plus something equals 60, that's got to be a 10. And then something plus 10 equals 58, that has to be a 48. All right, so that's how you would fill it in. Now sometimes they give you the whole two-way table and you have to do something with it. This would be how you'd fill in missing information on a two-way table. Okay, so let's look at number 2. What I want you to do is pause the video and fill the numbers on your own and then hit play and see how you did. Okay, so this one should be a 1 because 1 plus 29 is 30. Right here, this should be a 50 because 25 plus 50 is 75. This is a 45. 30 plus 45 is 75, and this is a 21 because you can look at it either way. You can go down, right? 24 plus 21 is 45, or 29 plus 21 is 50. All right, so let's take a look at number 3. We're going to have to make our make our own table. So it says a survey was taken of 100 families with one child and 86 families with 2 or more children to determine whether they were saving for college. Of those, 94 of the families with one child and 60 of the families with 2 or more children were saving for college. Organize these results in a two-way table. Find and interpret the marginal frequencies. Okay, so let's just start with the table first. So we have 2 different things going on here. First, we have families with one child and families with 2 or more children. So I'm going to make that the top. So this will be the one child column. And then this will be the 2 or more children column. And then you also always need a total column, okay? So right here, we'll put the total column. Okay, so that takes care of that, but the other thing that we're looking at is not just who has how many children, we're looking at who's saving for college and who's not. So we're gonna make a yes saving for college row right here, a no, not saving for college row right here. And then once again, we need a total down here. Okay, so that's what that should look like. And then just to make it look a smidge neater, I'm going to put some lines in here. So it doesn't have to be perfect like the example that we did above. But this way we can kind of see what's happening here. Okay, that works. All right, so let's fill in what we know. Get a marker. All right, so it says that it was 100 families with one child. So that means the total families with one child is 100. So that goes here because total one child. So we put 100 down here. And then 86 families with 2 or more children. So the total families that they talked to that had 2 or more children was 86. So that goes here. It says 94 of the families with one child were saving for college. So 94, yes, one child. 60 of the families with 2 or more children were saving for college. So 2 or more children, yes, saving for college. The 60 goes here. And then we have to fill in the rest. So let's add going across. 94 plus 60 is going to give us 154. 100 plus 86 gives us 186. And then we can start subtracting to fill in the middle row, right? So if 94 said yes, but there was a total of 100, 100 minus 94 gives us 6. If 60 said yes for this column, and there was a total of 86, this has to be a 26. And then I can just add going across. 6 plus 26 gives me 32. I could check my math by making sure that 154 plus 32 gives me 186, which it does. Okay, so what we did, we filled in the columns at the top with the title, so 1 child, 2 children, and then we filled in the yes and no here. Technically, if you were to flip-flop these, you would still get the same information. If I were to put 1 child, 2 child here, yes and no here, the numbers would move around, I think, but the data wouldn't change, so it doesn't matter where you put things. Okay, marginal frequencies. If we jump back to our definition page, it says that the marginal frequency is the sum of rows and columns. So basically, we want to look at the totals, the total columns, and see what they mean. Okay, so let's start over here. So 186. So 186 would mean that there were 186 total families surveyed, right? That's like the total. Okay. The next one we're going to look at is the, let's go here, 100. So 100 represents the total families, 100 families with 1 child. Okay. Let's look here at the 86. 86 represents the total number of families with 2 children or more. That takes care of that. And then let's go over here. So 154 represents the total yeses. And then remember, the total yeses were yes for saving for college. So 154 families saving for college. And then finally, we're going to look right here at 32. This was no, so 32 families not saving for college. So that's what it means to find the marginal frequencies, which would be, when we did this one as well, so it would be anything in a total column or anything in a total row. Interpret them means do this. So say, what does that 186 mean? What does that 100 mean? And so on. Okay? All right, let's turn the page. Let's look at number 4. So in a survey, 214 ninth graders played video games every day of the week, and 22 ninth graders did not play video games every day of the week. Of those that played every day of the week, 36 had trouble sleeping. Of those that did not play every day, 7 had trouble sleeping. Make a two-way table that shows the joint and marginal relative frequencies. Okay, so let's do this. We're going to set up the columns together, and then I want you to go ahead and fill in the information, and then you can check it with me. So the column, let's do every day here. So played video games every day would be here. Not every day would go here. And then as always, we need a total column here. And then we're talking about sleeping at night, right? So trouble sleeping at night, we need a yes, we need a no, and then we always need a total. Okay, so what I would like you to do, we can draw in our lines, what I would like you to do is pause the video and fill in the whole table. Okay, so you have to fill in what we know from the question, but then also the missing numbers by doing math. So pause the video, fill them in, and then hit play and see if we got the same answers. So those are the numbers you should have. If you have something different, pause the video and see where you went wrong. But you know, some of the numbers are from the problem, and then some I just did math, either addition or subtraction, to fill in. And then it doesn't say interpret, so that's all we have to do for this one. Let's look at 5. For financial reasons, a school district's debating about eliminating a computer programming class. The district surveyed parents, students, and teachers, and then here's the two-way table. Okay, so they're given as joint relative frequencies, which means they're already given as probability in a decimal form, but they're given as probability, sort of. That means that it's not the number, it's not like 0.58 parents said yes, it's basically 58% of the population. Okay, so what we're going to do is take a look at A. So it says, what's the probability that a randomly selected parent voted to eliminate the class? Okay, so if we're only picking from parents, we're only picking here, what's the probability that they said yes? It's already done for us, okay? So the answer here would be 0.58 or 58%. Either one's fine, okay? B says, what's the probability that a randomly selected student did not want to eliminate the class? So let's go to students. Not would be 0.15 or 15%. And then finally it says, determine whether voting to eliminate the class and being a teacher are independent events. So does one depend on the other? Does eliminating the class, does being a teacher depend on voting to eliminate the class? No. Okay, so it does not depend on it. So yes, it is independent. One has nothing to do with the other. Yes, teachers are being surveyed, but it's not like being a teacher depends on voting, because parents are voting, students are voting, everybody's voting. Okay, so that's it for that. So what you're going to do, you're going to move on and go ahead and do the practice. So you can see some of them you are filling in the table, some of them you are making tables. And that's it. So you're going up to just those 2 pages. If you have, no, just 1 page, even better. 1 page, lucky you. All right, cool. So if you have any questions, feel free to reach out to me. I miss you guys. I hope you're doing well, and I'll talk to you soon.